So we are discussing 8086 microprocessor. So today what we do is we will try to discuss the addressing modes of 8086 and few instruction sets of 8086. So we are coming like this, in the first we discussed 8086 architecture and its programming model. So in the last class, I completely discussed about the architecture, and then we have seen the programming model, and then after that, if you want to make a system, so how you are making, how you are connecting memory to 8086 processor, and we discussed like linear mapping and segmented memory. So in segmentation, memory segmentation, we are dividing the 8086 memory into two banks. One is even bank, another one is odd bank. So then we start writing program, like we can instruct the microprocessor to do a particular task, right? So then writing a program, right? So when you are writing a program, you should know which instructions the processor can understand. So then we should know about 8086 instruction set. Then once we know instruction set, if you are started writing program, it is like similar how you are writing a sentence in English, a new language. So when you are started writing, you start with learning alphabets, then you start knowing grammar. So this addressing modes is like grammar. So 8086, when you try to see, and this is what we discussed. Okay, this is what we discussed. Okay, so now if you try to see here, now 8086 instructions point of view, when you try to see, then let me go through this thing, slide mode. Yeah, let me share my screen. Yeah. So now when we are trying to look into a system and all, so now let us try to see the 8086 instructions, right? So let me take a blank slide. So now what we are doing is, this is our microprocessor. Okay, this is our microprocessor, and here we are connecting memory, right? So as a programmer, you have to know the programming model. Now the memory which you are writing is into the RAM, and this RAM is also divided into two banks. So this is even bank, right? This is an even bank. This is an odd bank. Okay. So these memories are connected to the data bus of microprocessors. So you can take it as the data bus. Right. So the data bus of 8086, right? The data bus of 8086 is of 16-bit, So then 8 bits you are getting from even memory, 1 byte you are getting from even memory, 1 byte you are getting from the odd memory. Total together it will become 16 bits. So the processor can fetch 16 bits at a time. So it can read into or it can write into the RAM. Right? So now let us take, you want to move a byte into a register S. So as a programmer, you are writing, so move AL comma, right, so move AL comma 05. That means you want to move, you want to move 5 into accumulator register. So you can, throughout my lecture, I'll try to take addition of 2 numbers. As a starting point, how do you write? So as a programmer, you are writing your instructions in the memory. The instruction can be of this kind. Like moving 5 into AL. Now, any instruction is of 2 types. Now let us say if you take one instruction, opcode and operand. Opcode will tell you or otherwise, see, this is what the instruction I am writing. Then microprocessor is a machine, it has to understand this English type words like moving 5 into accumulator. Alright? But we as a human being, so the programming, the moment you are trying to write a program, you can write into these many languages. You can write the program in assembly level language, right? And you can write the program in high level language. You can write your program in high level languages, right? So now high level language like C, okay, but it is a machine, it understands the program which is at machine level. Machine level means which is of zeros and ones. But now writing a program in zeros and ones is very difficult. So what we do, we write our program in assembly language. When we are writing our program in assembly language, like English words, move AL comma 05, then the processor should understand what exactly it has to do. So then what we do is, we will need, so this program is in assembly language, so we need an assembler. We need an assembler. This assembler will convert the assembly language program into machine level language programs. So we need an assembler. What does the assembler will do? The assembler will convert the machine level language into assembly level languages. Then this is a software, assembler is a software, a piece of code which will do these particular conversions. So then these things we will be writing in EEPROM or E square PROM. So to the system, in the next class I'll try to show you the system. So your ROM is connected, which is of EROM, EEPROM or E square PROM. So your assembler will be sitting in your E square PROM. The moment you are writing this instruction and compiling, then this assembler will convert this into machine level languages. So this instruction is of any instruction is of containing opcode and operand. So then this is opcode. Opcode means the processor will understand the moment it decodes this opcode, it understands which function it has to do. And this is operand. So any instruction is of opcode and then operand. Okay, if it is of opcode and operand. Opcode means it has to move a byte into the register accumulator which is available on the processor. And what has to be moved? A data of file. So any instruction is of opcode and operand. Then your assembler will convert these instructions into machine level languages. And as a programmer, so this is a 2-byte instruction. I'll try to come this particular point. So it is a 2-byte instruction. Then these 2 bytes will sit, right? 1 byte in even memory and another byte in odd memory. What is that? The converted byte, if it is a 2-byte instruction. So as a programmer, you are writing your program in RAM, in specific, the labs, if you go, then the labs, the boards which are there in the labs are having SRAMs. HY6226 which is a Hyundai made RAM chips. Right? Or you can find different company also, it doesn't matter. Now see, as a programmer, you are instructing the microprocessor to do certain tasks. Then you will be writing program. So how many ways you can write program? You can write your program in machine level language, or you can write your program in assembly level language. You can write your program in high level language. But writing program in zeros and ones which the machine understands is very difficult. So then what you are doing is, you are writing a program in assembly level language. So then the moment you are writing a program like assembly level language, the simple instruction move AL comma 05. So the moment you are writing your instruction move AL comma 05, then what happens? The moment you type this, then it will be converted into machine level language by the assembler. And any instruction is of opcode and operand. It is a 2-byte instruction. So the first byte will sit here based on your starting of the address of your memory location. 1 byte will be stored in even memory, another byte will be stored in odd memory. Alright? So, and you will keep on writing as a programmer the instructions. This set of instructions is called program. So you are keep on writing instructions. Then now, what is this addressing mode? The addressing modes will tell you, see, the addressing modes will tell you how to locate the data in the instruction. I repeat, coming to the addressing modes will tell you how to locate the data in the instructions. Right? So today's class, we are going to discuss Okay, today's class we are going to discuss addressing modes. So we are going to discuss addressing modes. All right. So now, what is this addressing mode? The addressing modes will give you how to locate data in the instruction. So like learning grammar. So you want to write program, well and good. But at the same time, you have to know the grammar for writing your sentences. So addressing mode is this. So let us try to see the addressing modes first. Right? So now let us try to see the addressing modes. So what is this addressing mode? The way of locating data in the instruction. Right? So how to do that? Now let us try to see. So we are going slowly. Right. So now let us try to this is yeah. So now let us try to see what is this addressing mode. So I'll try to take an example, and with the example I'll try to explain the addressing modes. So computer instruction is made up of an operation code and operands. The opcode identifies the operation to perform. So operands identify the source and destination of the data on which you have to operate. So the source and destination can be CPU registers and memories or IOs. So the different ways in which the microprocessor generates these operand addresses is called addressing modes. So each instruction needs data on which it has to perform the specified operation. So the technique of specifying the address of the data is addressing mode. Addressing modes indicates the way of locating data. So what is the meaning of addressing mode? When a CPU executes an instruction, it needs to know where to get the data and where to store the results. Such information is specified in the operand fields of the instruction, right? So now the addressing mode based on the instructions we are going to now if you the type of instructions, if you try to see the whole instruction which can be divided into sequential control flow instructions and control transfer instructions. I'll try to take up this in detail. That means when processor executes one instruction, then next instruction will be executed after that instruction. So the control is to the next instruction in the memory. But sometimes when you are performing a jump operation, If there is no carry, then do this. If there is a carry, then do this. Like those kind of applications when you try to do, then you will be using jump instructions. So the moment it is jump instruction, the control is transferred to somewhere in the memory. Okay, so that's why they are divided into two. And now sequential control flow instructions, the example are arithmetic instructions, logical instructions, and data transfer instructions. And based on these instructions, sequential addressing modes, the addressing modes for these kinds of instructions, we try to take it as sequential control flow instructions. For those instructions, how you specify data, then we give the names. The addressing modes can be called immediate addressing mode, direct addressing mode, registered addressing mode, registered indirect addressing mode, based addressing modes, indexed addressing modes, based plus index addressing modes, registered relative addressing modes, and base relative plus index addressing mode. So these many are there. So now let us go one by one in detail. Now, so coming to the addressing modes, you just try to take the list. Immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, based addressing mode, index addressing mode, base plus index mode, register relative addressing mode, and then base relative plus address indexing modes. Right. So now let me try to give you these addressing modes with the help of example. Right. So now listen carefully. Now the task is, I want to add, so write a program to add 2 bytes. This is the task given to you. Write a program, and we are trying to write them in assembly language program. So write a program, assembly language program, to add 2 bytes. It is 2 bytes. That means I have a byte 4, 5, and I have a byte 6, 0. So 2 bytes are given to me, and I have to write a program which can, so these are hexadecimal numbers is what you can consider. So these 2 bytes I have to add, and I will try to take this example and I will try to explain what are these addressing modes. So my task is to write a program to add these 2 bytes. Now what I do is, the moment it is known to me, I try to develop an algorithm. So how can I add these things, 2 bytes? So then the algorithm is move a byte in one register. Then the thing is, the next one is move the another byte. Move the another byte in another register. Simple. And then add bytes and then stop. This is a simple algorithm. That means you want to add 2 bytes. So move the first byte in one register, move the second byte in another register of the microcontroller, the registers which are available with microprocessor. Then add the first byte, means copy the first byte, moving, or you can say copy the first byte in one register, move the second byte in the second register, then add it, and if you want to add and then stop. This is what the general algorithm is. So now this you should bring in the form of a code. So that we have an instruction for moving. We have an instruction called move. So move. So now I want to move 1 byte in accumulator. So accumulator register is AL. The lower byte is what I use. So the first byte I move. So the bytes which I have taken are, I think anything you can take. So the moment is, it is 5, 6 and 6, 0. These 2 bytes I need to add. So move AL comma 56. Then move BL comma 60. So the moment the assembler executes the moment assembler is executing this, then when it is trying to see, this H indicates it is an hexadecimal number, so you have to write H. Then there is an instruction call. So move is one instruction which will try to move the data. We'll try to see these things in detail. There is another instruction called ADD. So add AL one register with the another register is. And then you can say halt, HLT, halt is one instruction to stop the execution, or you can use interrupts. So this is a simple program of adding 2 bytes, right? So this is what we'll try to write. Now, what is here? The addressing mode is what the concept we are trying to see here. So now let me explain this with the help of 8086 emulator. You have a software called 8086 emulator. Right, this 8086 emulator you can use, you can freely download. And this software, this is what the assembler is, what I told. You can write a simple program. So move the first byte. So move 56 in one register and move 60 in the second register, and add the AL content, the accumulator lower byte with the BL register. That means the lower byte of your base register, and then stop. So this is how you can write the programs. Then you can go to the assembler and then you can say assemble. So the assembling means it will tries to convert. Then now you go to your run mode, right? So then when you go to the run mode, it will be given like, so what exactly is happening here? Now you try to see. You have your program here, move AL comma 56. The moment you type, single step debugging when you go, then it starts from the first byte. And this gives me the memory field 01000000 means now in the last class I told you how to generate a physical address. The physical address is 20-bit address which is of 010000. At that particular point you are writing. And now the moment I say move AL comma B6, then your assembler converts that into machine level. So B0 is moving. Right. So the moment I execute this, earlier in accumulate AX register, in the top left if you try to see, the lower byte is moved in AL 56. So B0 is one machine level code which is converted by the assemblers. And what this opcode is B0, 56 is operand. So 56 has to be moved into the accumulator. So that meaning is written in B0, moving a byte in the lower byte of an accumulator. So the moment the processor executes this instruction, it tries to move 56 in AL. This is the first piece of program we are writing. So I am going step by step. Slowly I am moving. Then the next thing is move BL comma 60. So the second number is moved in BL. Now when you execute here BX, if you try to see, the lower byte is 0000. AL and BL and BH both are 00. But the moment I execute this instruction, 60 will be moved in BXS. So now what do you mean by here addressing mode? So the moment you are writing your instruction, right? So the moment you are writing your instruction, the opcode is immediately available in the instruction is. So here the 56 is the data which has to be moved into the accumulator is immediately present in the instruction. So those kinds of addressing mode, the way of locating data is called addressing mode. If the data is immediately present in the instruction, then that is called immediate addressing mode is. Immediate addressing mode. So what do you mean by that? A instruction is of opcode and operand. And the operand means the data on which you have to perform a task. So the operand, if it is immediately available in the instruction, and those kinds of way of locating data is called addressing mode is. Immediate addressing mode is. All right. So now let us go ahead with what is this immediate addressing mode and how is the syntaxes. So here if you try to take an example, move AL comma 22. So this 22 is the source, means the data where it has to be moved to the destination. So source is the data and the destination is in an accumulator, or it can be. So now if you try to take this move AL comma 7, right? So the machine code for this is this. This is a 7, and in detail of instruction if you try to go. I'll little later I'll try to discuss this. Okay. Now here, this is how you can start, slowly started writing programs. Okay. So now let me take the another sheet and then try to explain what exactly we did. We wrote a small program to add 2 bytes. So move AL comma 56H. and move BL comma 60H, add AL comma BL, and then halt. Now, this is not a good way of programming, because then I'll tell you, I'll give one more program. No, 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 not 56 and 60 has to be added. Something else needs to be added. So I want to add a number 68 with 52. So this byte has to be added, not that byte. Is what the next task is. Then what you do? Again, you write the same program, but here the data here need to be rewritten. So that entire program. So a byte is moved, or a word is going to be moved in the register. So here, but the data is there in a register, that is moving into the register. So source is the register and destination is also in a register. These kind of addressing modes where you copy your data in one of the register and then on that you want to work. That kind of register addressing mode, or that kind of locating the data in register is called register addressing mode. Source and destination both are registers. So move AL comma BL. If you try to take the content of AL, the content of BL is going to be moved into AL. Right. So immediate and register addressing mode, the processor does not access memory. Thus, the execution of such instructions are fast. Right. So the data is available immediately in the register. So the operations are going to be performed on processor only, because the movement of data is register to register. So it's very fast way of such execution of such instruction will be very fast. Then the next one is direct addressing mode. So what do you mean by this direct addressing mode? Now let me try to take up. Okay. All right. So what is this direct addressing mode? Now let me take up by taking in a new sheet. So I want to add a data of 56 and 60. So I want to add a data of 56 and 60. Then what I do is these 2 bytes. See, if you try to take the memory is divided into code segment and data segment. Right, code segment is of 64K and data segment is also of 64K. So then what I do is my data somewhere in the memory of the data segment I copy. So here now let me take, here I am writing my program. So my program just now we have shown 0100 0000 is my opcode where it is going to be stored. So my programming instructions opcodes are here, right, which are converted by your assembler. They will be stored in opcode. And then I want to place my data in somewhere 0200 0000. So here what I do is I try to copy the first byte 56 here and 60 here. So instead of specifying the data in the instruction, I'll copy or I'll specify this data somewhere in the memory, in the data segment. Right. So then what would be the algorithm is? So task is same. What is the task? I have to add 2 bytes. So then my algorithm is these data on which you want to add stored somewhere in the memory, and from that memory you have to copy. So then the first thing is point the memory by using a pointer. We have pointer registers like SI, DI, source destination index and destination index we have. So you can use a memory pointer and point out this particular memory is. That is your first step. Second step is copy the byte into one register. Okay? Then the next thing is the pointer, right, or otherwise no need here in this case, right, in this case it is no need, let me take it as a refresh. What you are going to do is the data which you have, you are placing in memory, and that memory address could be 0200, right, there the first byte is 02000001. The second byte is here, the first byte is here. So instead of specifying the data which we done in our previous program, like instead of specifying the data in the instruction, what we do is we will specify the memory from where we have to copy the data. So then what we do is, so then move AL comma 0000. That means instead of specifying the data in the instruction, we specify the memory in which it is there. So, but this 00 specifies what? So here what we do is move AX comma 0200 and move DS comma AX. Right. So this is, my data is at 0200. This means my physical address is what? 02000. This is my data segment address. Right. So then I cannot move this 0200 into DS. Then what I do is I move this 0200 in AX register and move DS comma AX. So the moment I write move AL comma 000 means from this memory, what is the data? That data is going to be copied in AL. So how we are locating the data? We are not directly specifying the data in the instruction. There is no data here in the instruction. We are specifying the memory at which the data is. So this kind of addressing mode is called direct addressing mode. Direct addressing mode. Instead of specifying the data in the instruction, we specify the memory location in the instruction. So specifying the memory locations in the instruction is called direct addressing mode. Then next what I do is move BL comma 0001. This 0001 is the next byte at which my data is. Right. So then I will say simply add AL comma BL and hard. So what is the advantage of writing this kind of program? If I give a data of 56 and 60 or 68 or 70, any 2 bytes if I give, my program will be same. But I simply going into the data segment and there I'll change my data. Right, there I'll just overwrite my data in data segment, that's it. So then there is no need of writing my entire program. Same program works on n number of data sets. That is the advantage of direct addressing mode. So this kind of addressing mode, how to do this in the lab is what we can try to see with the help of this emulator is. So this is what I am trying to explain. So move DL comma 6060, add AL comma BL, and then the result will be accumulated back in AL. So 60 and these two things are added and stored in a byte, lower byte B6. B8's content will not be changed. So halt means, the emulator will stop. That is your last thing. So this is 1, 2, 3, 4, 5, 6. So these bytes are going to be stored in our memory 0100 and 0006. Right. So then what I can do is now, so these are my, the way how I write my program in emulator. The same thing has to be done in your board. I think your instructor will take care of these things. Right, so I want to write these things in memory. So then what I do is, right, so directly you can write, your program is here, and then your data you can write somewhere else here in some memory. Instead of 0100, you can take 0200 also. So in 0200, you can place your data, and that particular data you can work it on. Is that all right? So this is how you can start writing piece of program. Okay? Is it all right? Are you able to follow me? All right? Yeah. So this is what we covered 3 addressing modes. One is immediate addressing mode. Another one is register addressing mode. Another one is direct addressing mode, and we have seen the advantages of one upon another's. Right? So this is what here if you try to see, now if you identify the addressing modes here, so this is the first instruction is of immediate addressing mode. This is of register addressing mode because the data is there in BL and data is there in AL. Add the content of BL with AL. So this kind of way of locating data, this kind of way of locating data is called. So this is a registered addressing mode, and this is immediate addressing mode. And then here, when you try to see, we are not specifying the data in the instruction. We are specifying the memory location in the instruction. So this kind of addressing mode is called direct addressing mode is. And then the next addressing mode is, we'll try to take up the next addressing mode now. So the next addressing mode is, so this is what is the direct addressing mode. Then you see the syntax of writing instruction. Move AX comma 2000H means this 200H is a memory, and the moment you write, that means here move 16 bits from memory into AL and AH, which is of AX. So then 2000 content will be moved in AL and 2001 content will be moved in AH because it is a 16-bit processor. So this is what the direct addressing mode is. So here if you try to take the source, here is a memory and the destination is a register. This kind of addressing, way of locating addresses, direct addressing mode. So this is what your direct addressing mode. Then now from where, you have to move a 16-bit into AX, well and good. From where it will move, then your emulator or your assembler will calculate the address like this. Your DS is your data segment register. The data segment register content will be added to 2000. I repeat, by default the data segment here is DS. The DS will be multiplied with 16 to add a zero, append a zero in the last, and then 2000 will be added. Example, if you try to take, if DS is 100 and your AX if it is 1234, so then this 1000 will be added to 1234, right? And then here now if you try to take an example, previous example only you can try to take, this AX will be added, then that will be your physical address, and that physical address, now let us try to take, this is instruction in detail explained. Move AX comma 7000. That means here source is a register. This register you can move. See here, the syntax is like this. Source is memory, destination is a register. You can have vice versa. In this example, if you try to take, move contents of 700 in AX. So that means now let us try to take the content of AX is 1234. DS register is 1000. Then the address will be calculated. DS is 1000 and then the memory address is 7000. So the 7000 is added to 100. So from 17000, what is the content it is there that will be moved. So the content here is 34. 34 will be moved in AL, and then 17001 will be moved in AH. And this is what, you know, calculating of your particular addresses. So here we have to talk about Little Endian and Big Endian. So Little Endian means your lower byte address is moved into lower part of your accumulator. Higher byte address is moved in higher bytes. So lower to lower and higher to higher is called Little Endian. The spelling is not IND IAL, it is ENDEAL. Little Endian. Intel follows Little Endian. And another one is called Big Endian. Big Endian means lower byte will be moved to higher and higher byte will be moved to lower. That is Little Endian. So now coming to the direct addressing disadvantages. What would be the direct addressing disadvantages? You have to completely know the memory addresses, and then from that memory you have to write into the programmers, which is a little bit difficult. So instead what you can do is, here if I give you, like, you know, if I try to tell you to add 5 bytes, so byte 1, byte 2, byte 3, byte 4, byte 5. So it is available in 0, 0, 0, 0 and 0, 0, 0, 1. That means the complete one is, it would be, you can try to take it here like this, 0, 2, 0, 0, 0. So 0, 2, 0, 0, 1, 0, 2, 0, 0, 2. 0, 2, 0, 0, 3, 0, 2, 0, 0, 4. So I have 5 bytes like 60, 52, 62, 58, and then 60. So the next task is given to is to add these bytes, like the assembly language program, to add these bytes could be the program given. So then what you do, if you use memory addressing mode, you will be writing program like this. Move AL comma 0, 0, 0, 0 is what you try to write, and move BL comma 0, 0, 0, 1 and add AL comma BL is what you can write. So then again move CL comma 0, 0, 0, 2 and add with carry. If any previously carry is there, then add C is, I'll explain this, don't worry about it. Add C, you can write here AL comma CL, then move something comma, you know, again you can use CL or you can use BL, no problem. So here BL comma 003. So that means you have to know all the memory addresses in detail, and you have to know all the memories from where you have to write, and then you can go ahead. So move BL comma, then you can write add C AL comma like this, you know, in the beginning, you know, add AL comma BL, so then move BL comma something, you know. So all the memory locations need to be pointed out in your particular instructions. So writing this kind of program is a little bit difficult. So then what we do is, the alternate is, we will use indirect addressing mode. So we will use indirect addressing mode is not the direct addressing mode which we talked about, where we are specifying the memory locations in the instruction. We will use indirect addressing mode. So what do you mean by this indirect addressing mode? Now let us try to see. So we have 5 bytes here, and then these 5 bytes need to be added. Okay, so then what I do, the algorithm is, this is the first class, and then you are writing as a program, and then most of you feel like microcontroller subject is very difficult. So I am going very slowly so that every one of you can understand. Right, so the algorithm here is this. What I do, instead of, this is what my 0200, where my first byte is there, 02001, this is my second byte, 02002 is my second byte. So what I do is, instead of writing these memory addresses in the program, then I point out this memory pointer and I increment the pointer. Then no need of pointing out this memory locations here. So that is what called indirect addressing mode. I will not point out the memory, I will not write this. So the algorithm is, what I do is point the memory location or the data segment by using, this is not data segment, you can say here the memory. Point out the memory means which your data is there. So point the memory. By default it is data segment only, by using pointer. Right. So then what I do now? Right. What I do now? Copy the first byte in AL. Then what I do? I copied the first byte in AL, which is pointed out by using a pointer. So then increment the pointer, memory pointer. So the pointer will point out this. Then what I do here, copy the second byte in another register, and then add 2 registers, right, and again increment the pointer. Okay, increment the pointer, all right, and then copy the next byte in AL, then add like this you go. So here what is the advantage? No need of specifying the memories in the programs, memory address in the programs. So then what we do here is, okay, right, so we'll start writing program. My data is there in the memory. Okay, so then what I do is move SI comma 0000. SI is the source index. I am using it as a pointer. Okay, a pointer. So before that, I try to write this instruction. Move AX comma 0200 and move DX